Alright, today we're going to talk about scientific notation, okay? Scientific notation is just a way of writing a huge number smaller, okay? Now, today we're going to learn two things. We're going to learn how to go from standard form to scientific, and we're going to learn how to take scientific and make it... Now, all standard is what you've always looked at, 2,300. This is standard. Okay, so y'all write that. This is standard. Okay? What we are going to do is be able to turn that into something that looks like this. This is scientific notation. Okay? This right here in standard form will look something like this. Okay? But instead of writing 0.0046, we can write 4.6 times 10 to the negative 3. Okay. Before the day's over, you should understand how to go from scientific notation to standard form, from standard form to scientific, and you should understand why we do that. You should also understand what a negative exponent and a positive exponent means. So, here I've got you a rule. If it's got a negative exponent, the number is the answer, okay? The standard answer. This is scientific notation. The standard answer, what it is in standard form, will be less than 1 every time. So if the exponent's negative, the standard answer will be what? Less than 1. Okay? If I were to take the decimal and move it to the right, it would only make my number bigger, right? So the answer wouldn't be less than 1, would it? So which way do I have to move it with a negative exponent? Left. So I'm going to move it to the left how many?
3 times.
1, 2, 3. And what's my answer? 0.0032. Now, anytime you have empty humps, what do you put in them? Zeros. Okay? So 3.2 times 10 to the negative 3 is in what form, Caroline? This is scientific. We just made it standard. Now if it's a positive exponent, you move the decimal in an opposite direction. Okay? So if it's a positive exponent, the answer will be less than or greater than 1? Greater than 1. So let's write that down. So our rule is, if I have a positive exponent, the standard answer will be greater than 1. Here I have a negative exponent, so my answer is less than 1. Now I give you the exact same problem. The only difference is the exponent instead of negative is. So the answer is going to be less or greater than 1? So I have to move the decimal. Instead of left, where? Right. So I got 3.2, and I'm going to move it 1, 2, 3 to the right because the exponent's 3. Now with the empty circles, I put 0, so I've got 3,200. Okay? This was scientific. This is standard. And the reason I moved the decimal to the right is because it was a positive exponent. Okay? You understand? A negative exponent, the answer is less than 1. A positive exponent, the answer is
greater.
Good. Now we're going to learn, this is scientific notation to what? Standard. Now we're going to do the opposite. We're going to take it from standard to... Now right here our goal is to take this, which is in what form? Standard, and put it in scientific notation. Now every scientific notation problem will look like this form. A number times 10 to an exponent. So I need to put right here, this is going to be the exponent. Okay? Now, all the exponent represents is the amount of decimal places you move. Did you hear that? All the exponent represents is the amount of decimal places you travel. Now, if the number is small, less than 1, the exponent will be negative. Well, is this number less than 1? No, so the exponent will be
a positive.
Okay. Now, the number you placed right here must be between 1 and 9.9. Did you hear that? It can't be less than 1. It can't be greater than 9.9. So I can't put 10, 11, 12. I can't put any. 30, I can't put that. It's got to be between 1 and 9.9. Okay? So, if I move, my decimal is right here right now, is it? Because there's nothing written there. No decimal means it's right there. Right? No decimal means it's right there at the end. If I moved it right here, that would be 320, wouldn't it? Can I put 320 here? No, because it's greater than 9.9. If I moved it right here, I'd have 32. Can I put 32 here? No, because it's greater than 9.9. If I put it here, that's 3.2. Is that okay? So let's write 3.2 right here. And how many spaces did I move it? I moved it 1, 2, 3. So what do I put as the exponent? Negative. Caroline, I told you, you can't worry about left and right.
Okay.
You have to worry about, is this number bigger than 1?
Yes, yes.
3,200
Yes.
is bigger than 1. So your exponent will be simple. If this was 0.032, this is less than 1, so the exponent would be, okay? Positive exponent, bigger than 1. Negative exponent, less than 1. Don't worry about left and right. You understand? Okay, so my answer would be 3.2 times 10 to the third. You see that? Number between 1 and 9.9. How far I moved. That's it. Okay, what you've got to remember is the times 10 each time. So you're going to put like 6 times 10 to the third. This means times just like this means times, right? Okay, so let's try some examples. Now, on this first one, I've got 3.65 times 10 to the what? Now, since the exponent's negative, the answer is less than 1. So I got to move the decimal which way? Left. Because if I went right, it would make it bigger, right? So I got 3.65. Which way do I move the decimal? Left, how many?
Left.
1, 2, and in these empty spaces I put a 0, so my answer is what? 0.0365. Now is that less than 1? So you got it right. This is scientific, this is standard. This one right here says 21.549 times 10 to the negative 3. Since it's a negative exponent, I move it to left 3. 1, 2, 3. So my answer is 0.0214 or 549. Okay? Now let's do one with a positive exponent. 2.3 times 10 to the 6. Now, I've got 2.3. It's a positive exponent. If I took it to the left, it would make an answer less than 1. So I have to go to the, okay? So I go right how many? What's the exponent?
6.
So I go right 1, 2, 3, 4, 5, 6. Fill in all my humps with zeros. So I've got 2,300,000. Now, y'all don't know where the commas go. They go every third number. You see that? 3 numbers, comma. 3 numbers, comma. See what I mean? Okay. So I want you to try those 8. Take them from standard to scientific. Alright, so the first one says 1,200, and it wants us to make it scientific. So we know it'll be something times 10 to the something. Okay? Where do I have to move the decimal to make this between 1 and 9.9? Between the 1 and the 2. So I've got 1.2 times 10. Now how many places did I move it? 3 places. And this was greater than 1, wasn't it? So my exponent is what? Positive 3. Not negative, but positive. You not taking notes, Caroline? You are? Right here I've got 30,300. Where do I move the decimal? Between the 3 and 0 right here? No, between this one? Okay, so I've got 3.03 times 10 to the what power? 1, 2, 3, 4. And it's positive because it's a positive number. Now y'all say, why did you include 0, 3? Any number that's not 0 you got to include. And all the zeros in between it you got to include. If I had 1, 0, 0, 0, 4, 0, 9, 0, 0, 0, and wanted that in scientific notation, okay, where would I put my decimal? So I'd have 1.0004009 times 10. And how many places did I move it? 3, 6, 9 places to the 9 pound. But you see, anything that's not a 0, you got to include. And you got to include all the zeros in between it. Okay? What about this one? 0.000068. What would it be? 6.8 times 10 to the what? Negative 1, 2, 3, 4, 5, 6. Now the reason why it's negative is because this is less than 1. What would this be, Kareem?
16.
Yeah, what would it be? What's that?
7.02.
7.02
That's 10 to the fifth.
times 10 to the 5th. Good. You understand? So today we learned how to take a number and put it from scientific notation to standard form, and from standard form to scientific